welcome back to Next Gen Manufacturing Nexus. Today, we're going to pull back the curtain on something that's quietly sabotaging the factory of the future: bad data. Yeah, it's messy, it's chaotic, and it's the single biggest roadblock to building a truly AI-powered operation. So let's just start with a number: $22,000. Let that sink in for a second. That is the average cost of a single minute of unplanned downtime in the automotive industry. A single minute. It's a brutal reminder that every second counts. And you know where so many of those lost seconds come from? You guessed it: bad data.
And this quote, man, it just hits the nail on the head. For decades, the most valuable information on any shop floor, the little tricks, the hard-won expertise, it wasn't in a computer, it was in people's heads. And as this incredible generation of skilled workers begins to retire, all that knowledge is literally walking right out the door. Poof, gone.
And hey, even when we think our data is digital, it can still be a total mess. Just take G-code. It's the basic language of our machines, right? But so often the code is generic and needs all these little manual tweaks on the floor. A change here for a tool, a change there for the coolant. Every single one of those tweaks is a gamble. It's a new opportunity for an error, for rework, for scrap. We're trying to build a high-tech skyscraper on a foundation of digital quicksand. So, all of this really brings us to the core problem we're tackling today. We call it the hidden factory chaos. It's this massive, glaring gap between the promise of AI and the messy, disconnected reality of manufacturing data. And this is pretty much what that chaos looks like in the real world, isn't it? The engineering drawings are in one system, the quality procedures are, well, somewhere else entirely, and the maintenance logs, good luck digging through 5 different spreadsheets to find what you need. This isn't just inefficient, it's actively dangerous. This is where rework comes from, it's why shipments are late, and it's how bad parts escape into the wild. So you have to ask yourself, right? With all this amazing technology at our fingertips, why does the shop floor still feel so disconnected so often? Well, the answer is actually pretty simple. You can't build a strong house on a shaky foundation. It just doesn't work. And that is exactly what we're talking about next. It's time to stop talking about algorithms and start building the data foundation. Because the journey to real, meaningful automation, it doesn't start with AI. It starts with getting your data right. And this comparison just lays it all out perfectly. On the left, you've got the old way, tribal knowledge. Information lives in notebooks and in people's heads. It's inconsistent, it's unreliable, and when someone leaves, it's gone forever. What we're shooting for is on the right: a single, unified source of truth, where knowledge is standardized, verified, and becomes a permanent asset for the entire company. So what's the first foundational block we need to lay? The modern tooling library. And you've got to stop thinking of this as just a boring list of tools. No way. This is a strategic asset. It's the one place that holds the truth about everything related to your tools. Not just their geometry, but the real secret sauce. The feeds, speeds, and other parameters that you know work on your machines with your material. So how do you actually get there? It's more doable than you might think. First, just audit what you already have. Clean house. Get rid of the duplicates and the junk. Second, choose a modern system that can handle things like 3D assemblies. Now this next one is key. Start small. Pick one machine cell or one product and just focus on getting that right first. Then you make it a living system. Every time a programmer finds a better way to do something, that knowledge gets captured for everyone. And before you know it, the library becomes the absolute heart of your programming workflow. Okay, so our foundation is solid. Now what? Now we connect everything. This next step is all about weaving the digital thread, creating a seamless flow of information that runs all the way from the design engineer's desk straight to the machine tool on the floor. And a really cool part of this is the idea of a digital container. Just imagine a single, tidy digital file that holds everything a machinist needs to do their job right the first time. No more flipping through binders or hunting for files. It's all right there. The 3D model, the manufacturing info, the setup sheets, the tool lists, and the verified G-code program. And the benefits here are immediate. They're tangible. Setup times drop like a rock because everything is clear and easy to find. You stop making that horrible, costly mistake of machining the wrong part revision. You're basically taking the guesswork out of the equation and empowering your machinists with the right information at the right time. This is where things get really, really interesting. A connected factory is awesome, but an intelligent factory, that's a total game changer. So what if this digital thread could be more than just a data highway? What if it could become a central nervous system that doesn't just pass information along, but actually learns from it? And that powerful question leads us right here to the brain of the smart factory, the digital twin. This is where all that foundational work finally pays off. The clean data, the connected thread, it stops being just a pipeline for information and actually starts to think. So, what is a digital twin really? Put simply, it's a perfect digital replica of a physical machine or a process on your floor. But the magic words here are live bidirectional connection. This isn't a static model. It's a dynamic simulation that's constantly being updated with real-time data from the physical world. And this image right here shows you the magic feedback loop. Real data flows from the physical machine to the virtual model. The model then runs simulations, predicts what's going to happen next, and sends optimized commands back to the physical machine to control the process. This is proactive manufacturing, not reactive. We're getting ahead of problems before they even happen. So how does this twin make its predictions? Well, there are two main ways. You've got your physics-based models, which use the fundamental laws of science to get a really deep understanding of the process. But the real powerhouse for adapting is the data-driven machine learning model. It just learns patterns directly from sensor data, which allows it to spot super complex relationships that pure physics could never model. So let's recap. We've built the solid foundation, we've connected the digital thread, and we've created the brain. So what's the bottom line? What does all this actually add up to? Let's look at the real-world results that become possible when this whole system is in place. The results speak for themselves, and they are absolutely game-changing. We're seeing companies slash audit preparation time by 80%. That $22,000 a minute downtime problem we started with, how about cutting that by 40%? And compliance? It just becomes a seamless part of how you work, not a last-minute scramble. This isn't just an improvement, it's a revolution. And let's be crystal clear about one thing. This technology is not about replacing skilled people. It's about amplifying their expertise. It's about taking that priceless tribal knowledge that we've been talking about and turning it into a permanent, intelligent asset that benefits the entire company, today and for years to come. So, the crucial point I want to leave you with is this. The AI-powered factory isn't a question of if, it's a question of when. The only question you need to ask yourself is, what are you building it on? Is your data foundation solid rock, built on standardized, connected knowledge, or is it shifting sand, built on data chaos and disconnected systems? The choice you make today will absolutely define your competitiveness for decades to come.